In this demo, we perform an AI-assisted SQL injection attack. To get started, I've opened Visual Studio Code with the files I'm going to use for the demo. First is vulnerable web app.py. Now this is a Python script that's going to run a vulnerable web application. Let's look at the code. Starting from line 1, these are the imports from the Flask framework. The Flask framework is the base class for our application. Request is used to access incoming request data, and render template string is for rendering templates from a string directly. Then import SQLite 3 on line 2. This imports the SQLite 3 database module, which is a lightweight disk-based database that doesn't require a separate server process, and it comes with Python. Line 4 is a fundamental part of setting up a Flask application in Python. Just understand that it initializes a new Flask web application, and it's the starting point for building a web app using the Flask framework. Okay, now I'll expand line 7. This is the database initialization function. This function sets up the SQLite database. The database named example.db will be created in the same directory as the script if it doesn't already exist there. So it creates and connects to example.db, drops the users table if it does exist, and then recreates it, and then inserts a default admin user. This setup is done each time the application starts, so that ensures that we have a clean slate for testing. On line 28, we call the initDB function that we just went over, and then, expanding line 31, we have the queryDB function. So this function is used to execute SQL queries on the database. So it takes a SQL query string and optional arguments for the query and a flag to return only one result. We're establishing a connection to the SQLite 3 database named example.db. We're creating a cursor object, C, which will be used to execute the SQL query. Then we execute the query on line 34. We fetch the results into a return variable named RV. Then we close the database connection and return the values. Then on line 42, we have a decorator. And in Python, the values prefixed with an @ symbol are called decorators. This is just a special kind of function that can modify the behavior of another function or class. This decorator tells Flask that when a user navigates to the root URL of the web application, the function index should be executed. Expanding line 43, when a user visits the root URL, it renders an HTML form for username and password inputs, which posts to the login route. And speaking of which, we'll expand line 53. So this route handles the login functionality, gets the username and password from the form data, and constructs a SQL query with these credentials. And then it checks if the credentials are valid. If valid, it returns a welcome message. If invalid, it returns a login failure message. Okay, the SQL injection vulnerability arises because the query string on line 59 is formatted using Python's fstring syntax with the user input directly inserted into the query. This means an attacker can manipulate the username and password input to alter the query's logic. This makes it susceptible to a simple SQL injection query, typically called single quote and comment injection. So the single quote finishes off the username component, and the double dash signifies the beginning of a comment. So everything following the double dash in the line is ignored by the rest of the SQL interpreter. So what does that mean? Well, it means it comments out the rest of the SQL query, effectively removing the password check, allowing unauthorized login as the admin user. And finally, on line 69, if name equals main, this is the standard Python idiom for a script's entry point. Now, note on line 70, this runs the application with the Flask development server. The debug equals true argument enhances our development workflow by providing automatic reloading, detailed error messages, and browser-based debugging. However, it should never be enabled in production for security reasons. Okay, let's run the vulnerable app. So down on the taskbar, I'll select the PowerShell icon to bring up the PowerShell terminal that I have open. In it, I'll type Python vulnerable-webapp.py and press enter and run the application. And it shows that it's running on localhost at port 5000. Okay, now down on the taskbar, I'll bring up a web browser, and in the address bar, I'll type localhost:5000. And that loads the app. Okay, now let's go back to Visual Studio Code for a moment, and I'll bring up the AI-assisted SQL injection Python script. Okay, here we're going to import the OpenAI class from the OpenAI module. Then we initialize the OpenAI client on line 4. Then I'll expand line 7, and this is my message content. Basically, I'm indicating that I have this web application with a login form, and I'd like to test it to make sure that it has no SQL injection vulnerabilities. I provide GPT-4 with some information about the web app. And then I ask for 10 payload entries that I can place in the username field to potentially test for SQL injection. I also give it some hints for output format. Okay, then expanding line 15. So essentially I tell GPT-4 that it's a helpful cybersecurity expert that's a part of my security operations team. And the second part of my message, I indicate my message content. Then on lines 26 and 27, I process the response from GPT-4 and print the results. Okay, so let's run the AI-assisted SQL injection script. So down in terminal, I'll type Python AI-assisted SQL injection.py. And now it provides me with 10 possibilities. So I'm just going to use the first suggestion. Recall earlier when I explained the vulnerability that existed in the login function? So here I have the single quote comment injection potential. Remember in SQL earlier I said that the double dash signifies the beginning of a comment. Well, we have the quote, which finishes off the username component of the query, and then we have the double dash that comments out the rest of the SQL query, effectively removing the password check and allowing me unauthorized login access as the admin user. So let's bring up the browser and we'll try that. So admin, single quote, dash dash, press enter. Okay, with GPT-4's suggestion, we successfully manipulated the username input to alter the query's logic. We effectively broke the password check, and hence we've successfully logged in as the admin user. All right then, with that, we've performed an AI-assisted SQL injection attack. In this demo, we'll use generative AI to detect web application vulnerabilities. Okay, to get started in my demo, I've opened Visual Studio Code with the files that I'm going to use, and we're going to perform two scans. We're going to perform a dynamic scan on a running application, and we're going to perform a static scan. In other words, we're going to get GPT-4 to analyze our code. Okay, so first, let's examine the vulnerability scan dynamic Python script. Okay, so line 1, I'm importing subprocess, and this allows me to spawn processes and connect to their input, output, or error pipes and obtain their return codes in Python. And just hang on to that thought, we'll come back to that. On line 2, I import the OpenAI class from the OpenAI module. On lines 5 and 6, I specify the Python interpreter and the path to the SQLmap.py script that we're going to use. Then on lines 9 and 10, we set up and run SQLmap as a subprocess. Now we're doing this with subprocess because there's no official Python library for SQLmap that we can just simply import and use within a script. We can execute SQLmap as a subprocess within a Python script though, and this allows for a level of automation and integration that can greatly enhance our testing capabilities and efficiency in performing tests like this. Okay, so line 9 is creating a list named command, and that's going to be used to store all the parts of the command that we want to run in the shell. It starts with the Python interpreter, then the SQLmap command, which is essentially the path to the SQLmap.py script, and we're going to clone a GitHub repo shortly for that. After that, we have several arguments that tell SQLmap how to behave, for example, -u and the URL, and then forms tells SQLmap to test input forms on a given URL. Batch runs SQLmap without manual interaction. We don't want manual interaction. We're automating this whole process. And then level 5 and risk 3, these set the level and risk tests performed by SQLmap to their highest settings. So this is the most aggressive and thorough testing. Line 10 is where the actual execution of the command begins. The subprocess run function is used to run the command. The command is the list that we just defined. Capture output equals true tells Python to grab the output of the command. Text equals true means the output will be captured as text rather than binary data. And this is helpful because we're going to feed the text information to the GPT-4 model. The result of subprocess.run is stored in a variable called result. Okay, then on line 13, we save the result from standard out to a variable for processing. And this is not strictly necessary, but it's good for further formatting the output data before sending to GPT-4, for example, if we needed to do that. We won't need to do that for this demo though. Okay, then on line 16, we initialize the OpenAI client. Then on line 19, so I'll expand line 19, is my message content, where basically I'm explaining that I'm demonstrating how to test an app for vulnerabilities. I'm running it on my local private network. I'm specifying that I'm providing it with the raw output from a SQL map scan, and I'm asking it to examine the output and provide me with a report indicating if there are any vulnerabilities detected and so on. I'm also asking for payload examples and the type of vulnerability from the scan. Now, for one web app, this might be overkill. I mean, we could just specify this in ChatGPT, for example. However, let's imagine that we had to test hundreds of web applications. We could automate the entire thing and run it through a loop and have the GPT-4 model provide us with a comprehensive report. Okay, so expanding line 25, this is where we send the data to GPT-4. And for messages, I'm telling GPT-4 that it's a helpful cybersecurity expert who's a member of my security operations team. Then I specify my message content, and that's going to be the content that we just described. And then the output data, which is just the output from the SQL map scan. Then on lines 37 and 38, we're processing the response from GPT-4 and printing out the report. Okay, so next we're going to clone a GitHub repo. And this GitHub repo is for SQL map. So I'm just including that in readme.txt. If I open readme.txt, it explains the GitHub repository and the command that we're going to use. Okay, so now let's go down to the taskbar. I'll bring up my browser where I've navigated to sqlmap.org. So SQLmap is just an open source penetration testing tool that automates the process of detecting and exploiting SQL injection flaws. Recall, I want to automate this entire process. So that's why I also had to import subprocess, because again, there is no official Python library for SQL map that we can just import and use within our script. So scrolling down the page, under download, I'll highlight the git clone command, right click, select copy. Now back over to Visual Studio Code. And in terminal, I'll right click to paste the git clone command in and press enter. Okay, so the SQL map repo has been cloned locally in a subfolder called sqlmap-dev. Okay, so now let's go down to the taskbar. I'll select the PowerShell icon to bring up the PowerShell terminal that I have open, and I've conveniently already specified the Python command, python vulnerable web app.py, press enter and run the app. Okay, and it shows that it's running on localhost at port 5000. Now let's minimize PowerShell. Now back in terminal in Visual Studio Code, I'll type python vulnerability scan dynamic.py and press enter. Okay, so this runs the SQL map scan against our application, and it provides me with some good information, including the fact that it is susceptible to a SQL injection attack. And it provides me with several details on the type of SQL injection attack, payload, and so on. Okay, so now let's do a static scan. So I'll select the vulnerability scan static.py tab, and here again, we're just importing the OpenAI class from the OpenAI module. Now, expanding line 4, here I'm defining a function named load source code and passing it file path. And essentially, I'm just loading the Python source code. On lines 15 and 16 are the file path and the call to load source code with the file path specified. Then we initialize the OpenAI client, and the message that I specify, my message content, is I want to perform a static security analysis on the source code for a web app. And I'm specifying that the following is the raw source code I want to have scanned, and I'd like GPT-4 to examine the source code and give me a report indicating the types of vulnerabilities that it found. Okay, so now expanding line 27, this is where I send GPT-4 my source code. So for messages, again, helpful cybersecurity expert who's a member of my security operations team. I specify my message content, and in a third message, I specify the source code. Okay, and then on lines 39 and 40, I'm processing and printing the response from GPT-4. Okay, so now down in terminal, I'll type python vulnerability scan static.py and press enter. And it comes back with an equally impressive report specifying not only the type of vulnerability, but it actually cites the lines of vulnerable code, and it tells me how to address the issue. All right then, well, with that, we've detected web application vulnerabilities using generative AI.